So my name is Lea Ann Dailey. I'm from the University of Vienna and I'm part of the Imptox project.
And what's your role in the Imptox project?
So I actually have multiple roles. Our primary role is manufacturing reference materials and characterizing them for our different project partners. But we're also looking into aerosol exposure conditions as well, because we have an interest in aerosol science and interactions with the lung and plastics.
Okay. And what are your expectations for today? What are you hoping for?
Well, I have to admit, I'm just so happy to be here in face-to-face and meet people that we've seen on screen for the past year. So that's the first the first thing that has really made this meeting special. And after that, I'm looking forward to really hearing a bit more detail about what everybody has been doing for the past year on the projects.
What is your motivation working on micro nanoplastics and health impacts?
Well, actually, I have been involved in this field for about 20 years. I started out working with biodegradable plastics for pharmaceutical purposes, and our main interest was looking at their interactions and their toxicity in the human body. And often we were using non-biodegradable plastics, a lot of the plastics that we're investigating today, as comparators to the biodegradable plastics. And so it was an easy switch for me to actually start putting the focus more on the non-biodegradable plastics. We already had a lot of expertise in characterizing plastic materials and looking at their interactions with cell cultures and even in animal models. So it was really a natural transition.
Okay, and so the pharmaceutical purposes, that was like implants or things like that?
It was implants, but also drug delivery vehicles primarily, and also for different routes of administration, including the lung, which is why I also have a special interest in interactions between nanoplastics and the lung.
So it's really kind of almost a leap from you want plastics to be taken up in the body to how do we measure those plastics that we don't want to be taken
Exactly.
up?
I mean, our previous intention always was to put in a specific dose of a biodegradable polymer to various organs to help deliver a drug in a controlled way. Using that knowledge that we had, we're now transferring that to see, well, can these plastics be taken up by the body non-intentionally, and to which extent? How do they interact with different organs in the body after different exposure routes, etc.? But what we need for these studies, of course, are well-defined, well-characterized reference materials. And because of our background in manufacturing different types of colloids, mostly from polymeric materials, we've also been working a lot on this. And it's a big challenge, to be honest.
What are the key aims of the CUSP Working Group 1 that you lead?
So the CUSP Working Group 1 is all about making the reference materials and characterizing them, and also deciding upon uniform features, key performance indicators, if you will, where we can all use the same types of characterization techniques as well as characterization endpoints, so that we know that the materials we're making within the entire CUSP group are harmonized. And we also want to be able to share the materials as well between the groups, so that the different projects can actually work on the same materials and hopefully then be able to compare their further results in the areas of toxicology and exposure.
And can you give us an example maybe of what the KPIs are? Like what are the characteristics that they should have, and also what are the biggest challenges?
So at the moment, our discussion has been focused primarily on sizing, because we have nanoplastics and we have microplastics, and the span of plastic sizes that we're all working with is quite large. And so we're focused on, first of all, harmonizing our definitions of what is actually a nanoplastic and what is a microplastic. And then we're looking at the different types of measurement techniques that need to be used for these different size ranges to make sure that when we all measure the sizes, we're doing it in the same way, so that we get the same results. And then we're looking at different types of size parameters that are harmonized with things like the ISO norm system, so that it's also, to a certain extent, normalized to standards in other areas.
So it's the sizing, that's an important one?
That's an important one.
But related to that, what's the challenge? I mean, is it the measuring? Or?
The sizing is a real challenge simply because most microplastics are not uniformly spherical. And a lot of sizing techniques rely on a theoretical spherical shaped particle. We have very rough surfaces, non-uniform surfaces, asymmetric particles, and they can, to a certain extent, cause differences in the size that you get, and the particle size distribution, which is also a big challenge because plastics in the environment are not all directly one size. They're a size range, and so we need to come up with good definitions of what the size ranges will be as well. And once we get through the size definition, then we start also looking at perhaps surface chemistry and other types of parameters that are also going to be extremely important when these particulates interact with the environment, perhaps are coated with products from the environment. This can be organic material as well as inorganic material, and that can be almost you could say a cargo that the plastic is delivering to the body as well, and this is part of the toxicology concerns. And this is all theoretical reference materials that are relatively pure. The next complicating step is, what do these plastics contain, and whether these materials that the plastics can contain, plasticizers or other types of additives, can actually leach from the plastics under certain conditions. Do we need to characterize this? And if so, what is the rate at which these other perhaps toxic materials can leach from the plastics and interact with the body?
Yeah, and also the non-intentionally added substances.
Exactly.
My pet topic. Okay. I mean, the CUS project has been running for just over a year now. 3 more years to go.
Yeah.
Do you want to just give us a quick look back on the first year and a look to the future?
Sure. So I can speak first from the perspective of the Working Group 1. So in the past year, we've met quite often, and we've been primarily gathering a survey about which plastics are being used within the CUSP projects and which size ranges we're particularly interested in. So we've got a nice overview now. And then we've started working on writing standard operating procedures for the characterization of these key performance indicators. In the next coming years, we're going to be focusing much more on these further characterization procedures, such as perhaps being able to write SOPs for the isolation of microplastics from complex matrices. These could be animal tissue or other types of environmentally relevant matrices. And then also the characterization techniques to be able to identify microplastics from complex matrices. What are all the different methodologies that are currently being now investigated? What is the state of the art? And are we as a group within CUSP pushing the edge of the state of the art further towards smaller sizes, and being able to look at both morphology of the plastics as well as the chemical composition.
Great, wonderful.
Yeah.
I could keep chatting with you for hours, but I'm worried it's starting, huh? Thank you so much.